Last one here, I said it was independent, which means it had a solution. And so let's take a look at how that happens. Let's check and see, first of all, how we know if it's independent. You can just start by trying to solve and see what happens. But we know that if they are inconsistent, they're parallel and have two different line intercepts because they're two different lines. If they are the exact same line, it's dependent. And so before we do any substitution, before we try and solve for x and y, let's just see if they're parallel or the same line. So y is already by itself here, y equals mx plus b. That makes it easier. So we're going to look then at the top one. We got to get y by itself. So if I add 6 to both sides, I get that y equals negative 2x plus 6. Now that is definitely different than the other line. The slope on this one, 2. The slope on this one, negative 2. Different slopes, not parallel. And so we can find a solution. They will intersect at some point. I've got them both set up with y equals. I'm going to do this one by elimination, just for funsies. So I'm going to take that second equation, or that first equation, I guess, y equals negative 2x plus 6. I'm going to use process of elimination. So I'm going to add. I'm going to say, well, y plus y is 2y. 2x minus 2x, 2x minus 2x, that's no x's. And negative 36 plus 6 is going to give me negative 30. 30, divide both sides by 2. You get that y equals negative 15. Perfect. That was the answer over there. So far, so good. So y equals negative 15. Now I know that y equals 2x minus 36. I also know that negative 6 plus y equals negative 2x. Neither one of these are perfectly set up, but I'll go with the top one, the top equation. So I'm going to use this and say negative 6 plus, well, I know y is negative 15 equals negative 2x. So I can combine like terms. Negative 6 plus negative 15 is negative 21. I can get x all by itself and see that 10 and a half is x, or 10 and 1 over 2. But 10.5, 10 and a half is x. So that's how we got that solution.